Hi, today I am going to discuss about thermal modeling of machine during offload condition. Last lecture class we have already gone through thermal modeling of machine during onload condition. Thermal modeling during offload condition. It indicates that for some duration of time our machine was loaded. Its temperature increases and the temperature of the machine is equal to or less than the steady state temperature. After that, the load is removed from the machine. Now, when the load is removed, current drawn from the machine, or you can say current drawn from the source, it will be reduced. Because of that, losses across the system will get reduced. Temperature rise across the machine will reduce. So here we will get different set of equations. We will solve those equations to find the temperature of the machine during offload conditions. So here we are going to discuss that one. So let's start that. Suppose initially the machine was loaded and its temperature achieved during some duration of time or load duration is theta 2. Just after that the machine is unloaded. Now its temperature keep on decreasing from theta to some other temperature as heat developed inside the machine is now get reduced. Let's take that value is P1 dash in joule per second. A new value of specific heat of dissipation is d dash. Then we can write this first order differential equation C d theta dt is equal to P1 dash minus d dash theta. Solving this first order differential equation, we can write theta is equal to theta ss dash 1 minus e to the power minus t by tau dash plus theta 2 e to the power minus t by tau dash. Theta ss dash is new steady state temperature. Tau dash cooling time constant of the machine. So theta is equal to temperature of the machine at any instant t. Theta ss dash, just like thermal modeling of the machine during loading condition, we can write theta ss dash is equal to p dash by d dash and tau dash is equal to c by d dash. If supply is removed from the machine, that means source is disconnected. Then P1 dash obviously it will be equal to 0 because P1 dash is heat developed inside the machine. As source is not there, so P1 dash is 0. Subsequently, theta ss dash is equal to 0. This indicates that machine has achieved ambient temperature. Putting P1 dash theta ss dash is equal to 0 in equation number 8, we are getting theta is equal to theta 2 e to the power minus t by tau dash. So it is observed from thermal modeling of machine during onload condition and during offload condition that the heating time constant and cooling time constant both depends upon a specific heat of dissipation. Tau is equal to c by d and tau dash is equal to c by d dash. Now this specific heat of dissipation can be increased or decreased. Suppose if we are using some cooling system or forced air cooling system we are using, then quickly the heat will be dissipated from the machine. So both tau and tau dash it will be reduced. That means quickly the machine will achieve steady state temperature during onload condition as well as during offload condition. Here a graph is plotted during onload and offload condition. When the machine is loaded, its temperature will keep on increasing. Here linear graph is plotted. It may be exponentially increasing graph during heating conditions. Similarly, during cooling conditions, the temperature of the machine will keep on decreasing. So it may linearly or exponentially will decrease to steady state temperature. Classes of motor duty. It means that there are some durations during which the machine are loaded. Some durations the machine is at rest condition. Some durations machine is at reduced load conditions or unloaded. So based on that one, there are different classes of motor duty, and these classes are continuous duty, short time duty, intermittent periodic duty, intermittent periodic duty with starting, intermittent periodic duty with starting and breaking, continuous duty with intermittent periodic loading, continuous duty with starting and breaking, continuous duty with periodic speed changes. So from these classes you can observe that it is continuous or intermittent. So continuous duty means your machine is always on. That means it may be unloaded or loading conditions. Short time duty means for some duration of time your machine is on, then machine is off. Intermittent periodic duty means difference between this short term duty and intermittent periodic duty is that in short term duty machine is off during long duration of time, but in intermittent periodic duty machine is off during short duration of time. Now, intermittent periodic duty with starting. That means some duration it is on, some duration it is off, like this. But during on also, initially it is you can say starting. Starting means during on-load conditions, it may be that at the time of starting, the motor will draw more amount of current. Then initially, because of that increased current, temperature rise it will be more. Though heating time constant is very large compared to the electrical time constant, but its effect cannot be ignored. That's why this intermittent periodic duty with starting is also a one class of motor duty. Then intermittent periodic duty with the starting and breaking. So during starting conditions, whatever temperature rise is there, then breaking conditions, change in temperature, we have to consider. Based on that one, we have to design the motor or select the motor rating. That's why these classes are important. Then continuous duty with intermittent periodic loading. That means machine is continuously on for some duration of time. Some load is there. Next duration of time, load is removed, but machine is not off. Then seventh one, continuous duty with starting and breaking. Continuous duty with periodic speed changes. In last three classes 6, 7th and 8th, machine is never off or rest conditions. So in continuous duty, machine is continuously on. In continuous duty, load is always there across the machine. So the straight line indicates that constant load is given to the machine. So TL versus T graph is there. Corresponding theta versus T graph, we can observe that its temperature increases from 0 to steady state value. In short term duty, for some duration of time, load is given to the system and enough time is allowed to cool the system. Corresponding theta versus T graph, you can see initially during one period temperature increases, then temperature decreases. Here we can say that cooling time constant is larger than heating time constant. This is a very important case. We will discuss in detail about these things in next class. Today we have discussed thermal modeling during offload condition and different classes of motor duty. Few more classes of motor duty we will discuss from next class. Then based on this motor duty, we will find rating of a motor. Thank you.